Hi all, welcome to Engineers Think Box. This is Sharu. As a part of Digital Signal Processing Lecture Series, I welcome you all to the Lecture 1 where we will be discussing the basics of digital signal processing. In this video, we will be discussing what is a signal, what are the types of signal, analog, digital, continuous and discrete signals and their differences, what is digital signal processing, block diagram of DSP and applications of DSP. So let's get into the session. What is a signal? Signal is nothing but a physical quantity that varies over time or space to convey information. Here what this physical quantity means is something which you can measure. So this signal acts as the backbone of communication system. The real-time examples which we could see in our daily lives are sound signal, temperature signal, voltage signal, ECG signal, EEG signal. These are some common types of signal which we could see in our day-to-day lives. So coming to the classification of signals, the signals are broadly classified into two types, analog signal and digital signal. What is analog signal? It is a type of signal where the values change smoothly. Smoothly in the sense gradually. As you could see here, the values gradually increase and gradually decrease. These type of signals are called as analog signals. The real world examples are voice signals and temperature signals. Coming to digital signals, it is also a type of signal, but here the values are fixed and limited. Unlike analog signal, here the values are fixed and limited, and these values are usually zeros and ones. That's nothing but binary values that could be easily understood by the computers. The main examples of digital signals are computer data and binary signals, which are obviously zeros and ones. Coming to the continuous signals and discrete signals, which are also called as continuous time signals and discrete time signals, these are not type of signals. These are the properties that are possessed by analog signal and digital signal. Coming to the continuous time signal, it is a property of analog signal, which means the signal will be existing at every instant with no gaps, that is with continuity. As you could see here, the values are there for each and every instant without any gaps. So continuous time signal is a property that is possessed by the analog signal. Coming to the discrete time signal, this is the property that is possessed by digital signal. Here the discrete time signals, the values will be specified only at specific time intervals and not continuously. Unlike continuous signals where the values are there for every instant, here it will not be like that. The values will be specified only for at specific time intervals and not continuously. So this is all about analog signal, digital signal, continuous time signal and discrete time signal. What is digital signal processing? In this slide, we are going to see what each word in this whole term digital signal processing means. Coming to the digital, it holds two meanings. The first thing is nothing but the digital signal which we have discussed earlier, that has fixed values and limited values that are nothing but zeros and ones. The another meaning is that the processing is done using this digital computer, so it is also called as digital for that case too. Coming to the signal which we have already discussed earlier, it is a physical quantity that varies over time which you could measure. And coming to the processing, it means that operating in some fashion on signal to extract some useful information. That is, you are going to operate on signal in order to extract some useful information. So with all these three terms put together, digital signal processing is concerned with representation of signals by sequence of numbers or symbols and processing of these sequence. Okay, now to understand this easily, imagine every real world signal around us, like whatever it might be, sound, temperature, heartbeat, or even images. All these signals exist in continuous analog form. But computers don't understand these continuous signals. They only understand numbers. Yes. So that's exactly where the DSP comes into picture. DSP is basically the technique of taking the real world signal, converting them into a sequence of numbers and processing those numbers to make the signal more useful. So the main purpose why we are dealing with DSP is you can estimate the characteristic parameters of signal, and you can also transform a signal into a form which is more desirable based on your requirement. So in order to make it simple, the one more example which I could give is camera doesn't store the real scenario. Okay, it will store only the pixel values. DSP will also convert any signal into the numerical form and works on it. So you could relate the working of camera with DSP. So now what happens once the signal becomes numbers, we can we can do so many things. You can remove the noise and you can compress it, you can expand it, you can analyze the patterns, you can extract useful information. These are the operations that are made. This is called as processing. So the main idea is understand the important characteristic of the signal and transform it into a clearer or a more desirable or more useful form. So now let's see how this happens in a typical DSP system using this block diagram. So what happens is everything starts with this input analog signal. This input analog signal might be anything like your voice or sensor output or ECG, EEG, whatever it might be. The signal first goes into ADC. ADC refers to analog to digital converter. Means it will be converting the analog signal to the digital signal. You can think of this ADC as a translator, that is going to get the analog signal and translate it into the digital numbers. As such, in order to make computers understand the signal. These numbers are then sent to the heart of the system, that is nothing but digital signal processor. This is where the stuff takes place, like which we discussed earlier: filtering, noise removal, enhancement, compressing, expanding, and all. All the processing of the signal takes place inside this block. After the processing, if we need the output back in analog form, we will send it to the DAC converter, that is digital to analog converter, where you will be converting the processed numbers into a smooth analog signal which is continuous in nature. And finally we get the output signal which is analog, which is usually clean, sharp, or more useful than original one. There are major difference between the input analog signal and output analog signal. This output analog signal can be used for your desirable works as it has undergone this digital signal processing. Coming to the applications of DSP, DSP plays a vital role in biomedical engineering, acoustics, radio detection and ranging, that is radar, speech communication, data communication, image processing, nuclear science, telecommunication, IoT and embedded systems. So this is all about DSP, the basics of DSP. I hope you would have understood something basic about DSP. So in the next video, let's see about DFT and the properties of DFT. Thank you.